Let's fix that. That's better. This here, this here. Can anybody hear me?
Yes.
Okay. Already started recording because why not? Let me go ahead and work on getting the practice exam pulled up first. All right. So let's go ahead and talk about some common questions people may have. So first off, you probably got my message that there were a number of people who decided to turn in something from Chegg. We were first alerted because a lot of you turned in, because a number of students turned in code and demo code to me, as among other TAs, that looked really weird. One of the things that was that like you had a bunch of programs all stacked together in the same program with a lot of if name equal main called, which is something I should have taught but didn't. A lot of redundant import statements, which is no need. You only have to import things once. And then we just kept seeing that. And then there's also a lot of similarities between them. But it didn't really require too much digging once we identified that a lot of students were turning it in, because all I had to do was I just simply said, hey, Chegg, do you have a pig? And it was essentially pig Chegg random.seed as a check. And after a couple checks, I was able to just when I did whatever search result I did, it was the first result. I just simply copy pasted some of the code from that I thought was a nice identifying string into Google and popped up with the first result. So I didn't even type that in, but that just gives it for me. And as you can see, it's a screenshot from my document. It's definitely a screenshot from my document and not somebody else's document, because I write my stuff using LaTeX, which means the font is in Computer Modern, which doesn't look distinctly different. It kind of just, you don't notice it as a font, which is kind of the point, because you've been inoculated to it, hopefully, from the fact that it is in almost all your, that basically pretty much every mathematics paper uses this font. It is the default font for when you write stuff in LaTeX. And I haven't found a better alternative, and it looks fine. It's also weighted specifically with margins, where it doesn't care about margins. It just simply weights things so that they're around 70 to 80 characters long, a good readable amount. And then this part is totally me, where I've selected Fioremano as the font for typewriter text and verbatim text. And as you can see here, this is the string that I essentially searched for, which was import random, random.c, def roll, return random 16 def game CPU. And that's the first line that pretty much all the offending students turned in. If you haven't met with me yet, and if you're a student who's gotten a notification, you need to meet with me. I don't hold any particular animosity towards any of the students who did this. I assume that that between COVID and all the other weird circumstances that have been happening in fall 2021, that the temptation to go and take the easy way out was just a bit too tempting. So I don't hold too much animosity, but this gets stopped now, and I'm stopping it now, and that is why I have submitted 27, which is now down to 26 academic dishonesty charges. The charges, the point of that is that they dissipate after a certain amount of time, but they effectively mean that there'll be greater consequences if it happens again, and basically I think there's like mandatory convening of conferences and meetings and stuff. But for here, I can just simply say this is the result, and the students can accept the result or disagree with it, in which case that prolongs the process. But I mean, I'm to put it bluntly, when I was explaining the situation to one of my friends who went through my PhD with me, he said, I'm going to paraphrase him. The only thing easier than cheating in programming is detecting cheating in programming. It is very easy. And so the consequences for those students is that basically they have an academic misconduct recorded. Full consequences of that, I'm not sure, and I'm asking for additional information. And they've got an automatic 0 on this assignment. And then anytime that they do any kind of plagiarism in the next 7 years, that will automatically prompt a much more severe response. However, I should warn you that anybody who cheats on the final will automatically fail the course. I will just auto fail you. It's okay to just say nope. I know that it was a hard assignment, so I'll keep that in mind for next semester. And that's fair enough since I'm dropping at least one. So, but cheating is not a victory there. And I'm going to figure out the appropriate way to balance this out. But yeah. So don't be dumb. So while we're talking about finals, I should talk and final grades. I should talk about the curve. Oh yes, there is one. But before you freak out, that's a good thing, not a bad thing. Okay. So first off, in my syllabus, you will have seen that there is a definite. Everybody can see the notepad that I just popped up, right? Okay.
Yes.
Okay. In my syllabus, you'll have seen there's a policy that basically if you get greater than or equal to a 90, that's an A, guaranteed, and that is true. The standard American grade formatting applies, that if you've got greater than or equal to certain rates, you get, so 90 and above are automatically A's, 80s and above are automatically B. Nothing that happens here changes that. So what typically happens is when I'm going through how I assign grades, the best way to explain the curve is to explain how I assign these final grades, because none of your raw points are going to get changed by the curve. If you got a 85.6 in the class in your points, then that's your final score. What changes is the range that is the letter grade range. Okay, so let's go ahead and so let's say I'm going through and I see basically here's some grades: 92.1, 93, and then the next grade below that is a 90.7, and then a 90.6, 90.2, and then we've got an 89.6. Oh, sorry, and let's go with an 89.6. Now that is very close to an A. I think everybody agrees that an 89.7 is very close to an A, right? Yeah. So it would be really, I mean, your professor would have, I mean, some professors are like this, but I feel like it's a very jerkish kind of thing to do. To say that this is an A. Sorry, this is definitely not an A, but this definitely is an A. All right. Okay, now let's get into the situation. What about this? Or this? Or this? Right? We're talking about how my curve policy works, right? So like, there's not really much of a difference between this grade. We've already established that this should probably be an A. And honestly, 1/10 of a point is not much of a difference between this and a 2/10 or 3/10. It's not much. So let's go with, and then let's say the next, so the way I've determined this is I don't look at any particular student. I just sort your grades from highest to lowest. Okay. And this is exactly the process I do. And I'm like 88.7, maybe. Let's go ahead and do 88.9 to get my point across. 88.5, maybe we're seeing something. But then if the next grade after that is an 87.2, right? I feel like it's, I personally feel like it's appropriate to put the cutoff for an A right there. Does that make sense? So I essentially look for a noticeable non-trivial gap. Typically that's a couple of points. It's not usually this close. So how does that factor for grades? Well, everything over here becomes an A, and all these students get an A minus. That makes sense? Yes, yeah. I determine your final grade regardless of your percentage. And yes, you have up until December 6th. I meant to run the grader again, and I meant to run the merge again. I ran the grader. I meant to run the merge again with it, but I was busy Sunday night. So that is how basically it works. So if you get above the cutoff point for any grade, so 90, so your standard points, 90 and above, 90 and above, 80 and above for a B, 70 and above for 90 above for a B, 80 and above for a B, 70 above for a C. Those are all kind of the, you're assured that letter grade. The minuses are how I extend the range down to round up the people to round anyone else. Does that make sense? So if you get a minus, that means your grade was on the threshold of becoming an A, and I did not think there was a significant difference between the A's because GPA wise, this is a 0.7 difference between this score. But what about this student? This student's probably going to end up with a B plus. So I look for the next kind of break. And if I see basically we've got a clump of 87, 87 point, and 86.8, and then the next score is in 85 after that, which is another break. So these two scores are similar, but maybe the next, let's be a bit more. Maybe the next score is like this, 84.9. That's probably where I'll make the determination for a B. But again, guaranteed, you're going, if you get an 80 or above, you're getting a B. So basically the curve, what does the curve do? It affects A minuses. So it changes B's to B pluses and A minuses, and C's into C pluses. I don't give out, I very, very rarely give out C minuses. C minuses are reserved for my personal judgment, where I believe that that the grade does not, that a failing grade does not represent the student's understanding of the material. As far as I'm understanding, and please, for the love of God, correct me if I'm wrong, my understanding that A minus, then A is a 4.0 in your GPA calculations, whereas an A minus would be a 3.7, and that a B plus is a 3.3, and a B is a 3. At least that's how it worked at my old institution. Please, for the love of God, correct me if I'm wrong, or speak up if I'm right. Okay. Okay. So the reason for this is because my objective, basically my objective is to determine kind of what's going on. If I could, if I could instead grade you by just saying pass and fail and then have a comment, a Twitter length comment for your performance, that would be my ideal way to do it rather than doing A, B, C, but that's qualitative. And we like quantitative stuff. So, so B minus would be a 2.7. So again, the entire point is to be fair. It is to basically say, you got almost an A, but what about the people below you? Is there really a difference between a 89.6 and an 89.4 other than luck or a single day late, which may have been something out of your control, right? That's what this is about. Okay. So that is how the curve for your final grade works. There is, and again, I want to emphasize, there is no curving of points anywhere. Your raw grades are calculated as is. So what you see is what you get. It is the range that I am curving. Generally speaking, you need above a 70 to pass the class. And that hasn't changed since day one. I don't think I've dropped. I think the lowest grade I've passed a student with a C minus is in the 68 or 69 range, but so below a 90 will always be an A minus, pretty much. Below a 90 will always be an A minus if you're getting curved up. Because I feel that there is a distinction, I believe, between getting that raw A and otherwise. Chag Sameach as well. I hope you had your fill of latkes and jelly donuts. So that is the way the curve works. It generally helps students. Generally, the vast majority of my students who, so about a third of the class get 25% to a third of the class, depending on the semester, gets a D, an F, or a withdrawal. You know, that they all get lumped together. Okay. If you, and F is reserved for people who don't turn in their final project and don't turn in their final exam. So if you didn't do, or that should probably be an or. So basically, if you failed the course by not trying, that's how you get an F. If you've tried this course and you tried your darndest, but it just didn't work, you're going to get a D or D plus. Because, and this has to do with me, with a fight I've had with the academic office, the bursar's office and student financial aid, where basically they give us where we've received contradictory instructions. Will the final exam be hard? The final exam will be very similar to quiz 6. So if you want to know what I'm expecting, check out quiz 6. Be sure to do quiz 6, remember, because there will be 6 quizzes total and I'm dropping the lowest. So there is literally nothing to lose by trying that one. Oh, that is a great thing. Will I let you know who is exempt from the final exam? Of course I will. Quiz 6 is due December 6th. Oh, sorry, December 6th, which is the last day of classes, because that is the thing. Yes, there is exemptions from the final exam. The best projects get exempt from the final. That is the reward. With the permission of the other students, I can say what the best is. The way it works is that I will I have the your TAs send me a short list from each of their sections So each section's like the best of each section, and from then those I will determine it. In the past, I've done anywhere between 3 and 5 different projects, and all their members from those projects exempt. So I've done 3 to 5 projects. So that's anywhere from 3 to 15 people being exempt. Winning projects in the past have been games. Winning projects in the past have been just simply a script that scans a barcode for somebody signing into a dojo and then automatically pulls up the web page, saves in a file, and then runs another script that opens up all the web page and then manually moves the mouse and keyboard to enter in all that information into the appropriate forms. If you do get exempt from the file, what happens to your grade? Your grade gets calculated basically the way you'd see it, where basically there's just no grade for the final. So I don't put in 100% for the final. It just never becomes a factor into your grade. If that makes sense. Because Canvas is more than able to calculate your grade based off of not having. Can you choose to take it even if you're exempt? Sure. So I will notify, I will try to have the teams notified by Thursday or Friday. That is why this is part of the reason why why late projects aren't really a thing. If you want to still take it, let me know. We can do the calculations. Okay. If you want to be masochistic. Because I mean, it's just, I don't think it's possible for it to help your grade. If you're interested in seeing what it is, then sure, you can take it as well. Does that make sense? Will I go over quick 6 after it's due? I can. Let me set myself a reminder to do that. I will, so give me a second to, give me a second to pause my screen sharing. I'm going to go ahead and add it to my to-do list. Create quiz 6 review video. I will create a review video for quiz that goes over quiz 6 after that. I will post after that day. Make sense? Where will you be able to find it? I will broadcast it on an announcement and on YouTube. I'll post it on YouTube as a YouTube video, and I'll broadcast a direct link to it. I'll make sure that everybody can get to it. All right. Now with that, I am sure that a lot of you would like to maybe get some do some practice problems for our final exam. Before we move on, are there any questions with what I've discussed? Also, I want to elaborate that it is very difficult to fail the final project. Doesn't mean it's easy to get an A. It's just hard to fail it. To completely and utterly fail it, you have to plagiarize, not turn something in, turn it in very late, like a day late, or to basically do some, say you're going to do one thing and then completely do something else. How long do the videos have to be? That's in the description for the final project submission, but please don't make them that long, like definitely less than 5 minutes. Yes, you can use, so it is cool if you use different tutorials and credit them. Yes. As long as you cite it's cool. I'm never going to hit you with an academic dishonesty. So I had 2 students who used the Chegg, this web page, but they cited it. Those students just receive a 0. They got no academic dishonesty charges. Does each group member need to submit a different video? No, but you all need to make a submission and link to the same stuff. Okay, can I overgo citing again? Yeah, just all they did was put in a comment. They copied the URL and put it in a comment and said they got it from there. Would citing on the final give you a 0? So citing on the final exam, What would citing on the final exam do? It depends. If you've looked for the exact answer and copy and paste the exact answer in. However, so full disclosure. Yeah, they got a 0 because they didn't do their own work, but they weren't dishonest about it. And I'm going to message them independently to make sure that they understand they do have the opportunity to return it back in before December 6th. But that's all about, but again, it's because they violated a classroom policy there. I can, Melanie, I can meet with you about that at some other point. Yeah, you can submit old labs, but it's up to your TAs as to whether they're going to take them, whether it's more than 2 weeks late or not, you know? Any textbook work, because that's automatically graded, will be graded. Regex is just an extra credit assignment. It's worth 15 points. No, you will not get a 0 if you use a tutorial from YouTube. So, okay, let me be clear. Let me pull up the syllabus, okay? Just so that I can try to be as crystal clear about this. I know that it's confusing. Part of it is I am a bit more lax on this than other professors are, in terms of what because of the nature of coding, where basically you get an error and somebody says, put in this line and fix it. And it fixes it. Okay. So here is what is reasonable. Communicating with other students, discussing class material, helping a classmate identify a bug, incorporating a few lines of, and here's the context, a few lines of code that you find online or elsewhere into your own code, provided those lines are not themselves solution to the assigned problems, and that you cite these lines of origin. So basically these are, if you find a few lines that help you fix something or help you do what you need to do and you cite it, great. What I'm concerned about is, so turning to the web or elsewhere for instruction beyond the own course, for references, for solutions to technical difficulties, but not outright solutions to the problem sets. Whereas not reasonable is, let's see, failing to cite, and then soliciting the solutions to the problem set online, splitting the workload among multiple people, and combining them. And then let's see, viewing another solutions to problem set and basing your own solution on it. Let's see. Yeah, finding code online that addresses the question on an exam and failing to cite it would violate the policy. And then, but basically searching for or outright soliciting solutions to problem sets online or elsewhere. So basically, yeah, if it's like, okay, I've got this bug and I'm trying to fix this bug, that falls under reasonable. I'm trying to solve this whole entire problem. That's where it falls under unreasonable. Does that make sense? However, where does the whole getting, yeah, you can totally follow a tutorial and change. And if you change it to make it your own, that's okay. But definitely games are complicated. I want you to basically, if you follow a YouTube tutorial to build a game, I think that's very viable, but generally you want to add on to it to make it your own. If you're a carbon copy, if you're a near carbon copy, you're probably not going to get an A, but that'll be fine. There'll be an interesting learning experience as long as you've learned and grown. I want you to try, as long as if you're worried, you can make an appointment with me. I'm available. Send me an email. I'll be available pretty much every evening, starting Wednesday evening. Okay. So if you've got any specific constraints, but if you're worried about it, just ask, and go into specifics with me. Okay. And now is not the place because it is lecture and I want to try to get onto that stuff, but I will be happy to go over those with you. In general, ask. In fact, or you can say, if you find something and you're not sure, you can always anonymously let a professor know that their stuff has ended up online. Now, with regards to the final exam, here's why you should not be worried. Okay. Problem one is unique. I always make problem one unique because it's easy for me to make it unique. Makes it also very easy to track when it ends up on Chegg. So problem one, there's basically no chance that you'll be able to plagiarize. But there's stuff like if you need to find, if you grab something like that is a, and if you find some hints and stuff, just cite it and it will be fine. Trust me, on problem one, there's pretty much no chance that you can plagiarize other than like submitting your answer to Chegg and then copying the answer you get from Chegg, which is in violation of many of the rules on like 7 different rules. So, that was very much so interesting. Did I say something weird? Oh, okay. Yeah, they yeah. Again, it's part of it is because you don't, as a lot of people who go to Chegg or some other service to try to cheat or plagiarize, they don't necessarily realize how easy it is for me to find it. And again, I'm very good at kind of finding it. Remember, pattern detection is a subdomain of computer science. And if you haven't figured out from the scams from the scam games and the scam kind of evaluations that I like to look at, I like thinking in a very in a manner with a lot of guile and subterfuge. So I do understand how people think like that, or at least I like to think I do. All right. So let's go ahead and go and talk about what's going to be on the final exam. Just again, problem one. So that is classically what I've done in the past. And I've shown you how to do that. Was there a runestone chapter on regular expressions? No. But if you go to automatetheboringstuff.com, which is another textbook we have listed in our syllabus, and I specifically listed just for this chapter, Automate the Boring Stuff, chapter 7 covers how to do regular expressions. This problem tackles read, writing, string manipulations. You don't necessarily need regular expressions to solve it, but boy, does it reduce the number of lines you have. Yep, this lecture is being recorded. Question 2 on your final exam. So let's go ahead and let's see if I can do that. Hold on a second. This is a feature in Python I didn't teach. Period. Here are some scenarios where it is useful. And here's how you use it. And here's a link to the documentation in case you're curious. Period. Here's a problem that's suspiciously similar to the kinds of problems I just described. Period. Solve the problem. E.g., here I'm testing you on the ability, can you learn? And as I've shown in the previous semesters, example, a set. So count the number of unique words in a file. Number 3. The number 2 is terrifying. It's actually not that bad. Yeah, that is a problem I have to change after telling you what sets were. So sets, right? They count the number. They basically are useful at holding unique things. If you add something to a set that already exists in the set, it rejects it. So you just simply add every word to the set and then ask how long the set is or how big the set is, and there's your answer. Oh, you totally could solve that with dictionaries and just simply count the keys. But a set is essentially a dictionary that has only keys and no values. Very good. A lot of the problems I'll probably do a problem that you can solve without using that. But it becomes much easier if you use that, like a couple lines simple. So number 3. So notice that basically, if you study for number 1, that's going to be somewhere between 7 to 10 lines. If you study for number 2, that solution should be, again, less than 10 lines. Or if you understand, and not so much study, but understand how to think about these things. The Monte Carlo one is the other one. I'll be giving you a toddler game, a game that has one purpose and one purpose only: to teach kids what a game is and teach them concepts like turn taking and the concept of winning and losing. If you want frequency, Anthony, that is best reserved for a dictionary. So number 3 will be a Monte Carlo approximation, and the description of it will be broken down point by point. So those are the 3 questions I'll be asking on the final exam. So, so again, this and this are part of quiz 2. Or sorry, quiz 6. So let's go ahead and look at some previous stuff. Let's open up exam practice 3, my old exam 3. I don't think I have an exam 3 saved here. That's okay. Exam practice 3, an old final exam, and the practice final, I believe I sent out. So let's look at this. So these are these irregular expressions complete? You should recognize this one. Oh, you might recognize this one from the one we did, which is write a script that, given a text file, returns and finds and returns a list of all the superhero words in it. That's a good one. I'm going to look through and see what kind of questions I have here. Yep, so I'll go through a couple of these and do these here. Okay. Then here's a former final I gave. Here, notice that the social security number was there. And FizzBuzz, which is not there because that's so well known you can Google it. But we will do that in class. And then practice username. Where was the Monte Carlo? Monte Carlo might have been practice, might be in exam 2 and exam 2 practice. So for that, so I know what problems I'm going to review now. So for the Monte Carlo approximation, though, while it's 3 questions, you may be worrying about failing them. Take a look at basically the fact that I always break it down. Like, here's the simulation. Simulating 10,000 dice rolls, handling doubles, so I break it down into how it works. Okay, so we are going to do a couple of practice problems. Let's start with this one for Monte Carlo. Okay, so the outcome of any fair let's get started with this one. And if we don't get through enough problems, I'll record another video over the study days for you. So if I don't get to everything I wanted to, a lot today was having to deal with administrative stuff. So the outcome for any fair coin toss has an equal chance of landing on Tez or Hale. Agree? Everybody good? We're in agreement. Great. Okay. If I were to toss this, if I were to toss a coin 3 times in a row, there are 8 equally probable outcomes, right? Three tosses of the coin, there's 2 results each time. So 2 times 2 times 2, 8 possible different outcomes, right? And I'll list them here. 3 heads in a row, head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, Ted, Ted, hail, Ted, Ted, tail. So, you know, H where it's head and T is tail. So this is head, head, tail. So suppose I challenge you to a coin flipping game for $100. Pretty tempting, right? You will choose the sequence that occurs at, so you're going to choose a sequence that occurs. So one of these 8 sequences, like head, head, tail. And then Professor Rosen will choose one, such as tail, head, head. One of you will keep flipping the coin until one of our 3 sequences occurs, and whoever shows up wins. So for example, if we will flip the coin until one of our chosen sequences occurs. And a few games might be, so notice with this. So we flip heads, then tail, then heads, then tails, then heads, and then tails, and then it goes heads, heads. So we finally got a tail, head, head. And so I win because I chose tail, head, head, and you chose head, head, tail, right? So then we play again. You flip head, and then you flip tail, you win. And then you flip tail, tail, head, head. Oh, we got a tail and 2 heads, so I win. And then if we you keep flipping heads in a row, and then you finally flip the tail. Oh, you won. Everybody kind of understand that? We keep flipping, and we're remembering what the 3 most recent flips are. And those 3 most recent flips are one of our combinations. We win. Does that make sense? Okay, so it seems like a fair bet. After all 8 outcomes of flipping the coin equally are equally likely. Then you remember Professor Rosen mentioned he was sorted into Slytherin house and is a bit of a trickster. He probably wouldn't be challenging you unless he makes sure he was going to win. So we will write a program on the next page to simulate this game. This is called Penny's game, by the way, P-N-N-E-Y. There's a link to it, or you can just Google it and on a number file. Did that? I will share this PDF later today. So write a program that simulates the game on the previous page with one. So, okay, let's boot up idle. And I'm going to do this. Okay, and new. So, okay, and so we want to do this. Have your game simulate 100,000 times and print out the percentage of times the other players win. Okay, this one didn't have a guide for what the score was, but that's okay. So first thing first, let's okay. First things first, let's go ahead and make a we need to import random, right? I will send out a reminder as to when the exam is, but I believe that is the correct date. Import random. Okay. And remember, if there's anything that prevents you from taking the exam that day, including on the day of exam, email me so it doesn't turn into a disaster. Okay. Like if you get into a car crash or something, or if you wake up and you're suddenly sick, and or if you wake up and you suddenly discover you're patient 0 of another Greek letter of the coronavirus, let me know that you're not going to make it to the exam. So import random. So let's go ahead and just do a simple method that's going to represent a coin flip. Okay, flip. And I'm a bit rusty, but I'm going to say return random because it's been a week since I've had to code. Return random dot choice. So random dot choice is useful. You just provide in a sequence of things, a list of things you'd like to return from, and it will give you one of them. So rather than doing 1 or 2, because we're talking about heads and tails, we're going to do heads or tails, right? You could do it however you want. This is the way I want to do it. And I'm going to test it by doing print flip right now, just to make sure that this works. Source must be saved, boom. And that gives me a tail. And then let's just test it heads. Great. So it gives us 2 different results. So, okay. So this is saying, hey, simulate this game with one player trying to get head, head, tail, and the other trying to get tail, head, head. So winning, let's go with, so what was the sequence? So head, head, tail, and tail, head, head. So you have, so the winning sequence for you is equal to head, head, tail. And Professor Rosen chose losting, well, tail, head, head. Now, why I chose this sequence, it's because I'm, of course, cheating. I'm not going to bet money if I don't have a better than good chance of winning it. Makes sense, right? So winning, losing, those are the sequences. And so we need to simulate 100,000 of these games. So for blank in range. So let's go ahead and write. If I were to be giving this as points, I'd say there's some points for simulating a single coin flip, right? And then I'd say here's a greater amount of points for simulating an entire single game. Then I'd say here's a number of points for simulating 100,000 of these games and collecting the results. And then finally, a few points for calculating your winning probability. Make sense? So, but I'd basically list those out so that you'd have kind of hints as to what you should do. So let's simulate an entire game. Okay. So let's go ahead and say winning. Let's go ahead and do winning. And let's make it so that we can change this game and see stuff later on, possibly. So winning, losing. It doesn't matter where these are. So now that I've passed them in. All right. For I in range 3. So first thing is that it's not going to, we're going to keep. So we have to do at least 3 flips, right? We have to do at least 3 flips because a winning sequence is 3 long. So I'm going to go ahead and do that. Let's call our sequence is equal to empty string. So sequence of flips is going to be sequence plus equals, and then we're going to flip the coin. Make sense? So we're going to flip it 3 times. So we have 3 flips. And now we don't know how long we need to flip it for. But what I'm going to do is say while the last 3 flips is not winning or the last 3 flips is not losing. And in fact, we don't, while. So let's see, what is the last 3? So that would be, this is easily determined by doing a slice. -3 to the end. Right? Or if you forget that notation to get the last 3, you do length of sequence -3 to start 3 from the end and go up to the end. So a lot of this in Python becomes very simple if you remember what the shortcuts are and how and why they are the shortcuts. So while the last 3 things in the sequence is not equal to winning and I don't want to save this in a variable because those last 3 things are going to change, as you'll see, every single time we call this. And sequence, the last 3 things in the sequence are not equal to losing. It's very important that I do the and, not an or over there, because I want to make sure it's neither of those things. Okay. So while it's in the last isn't that and it's not that, it's a very common logic error to make. I still make it occasionally. But because I teach this, I know especially to look out for it. So while we haven't found a winning sequence, I'm going to add on to the end of it and just keep doing that. And then when I'm done, I'm just going to, I could return the winning or losing sequence. But honestly, I'm just going to return, I'm going to be lazy and just return the last 3 characters once it ends. So if you, so let's go ahead and simulate a game, print game. What's the outcome if you input sequence? That is a great question. If it's :-3, that means go up to, oh, that's everything before. So if you do this, that's very different. That's everything in the sequence but the last 3 characters. So definitely would not get you what you wanted. So this is the last 3 characters. Starting at and going to the end. Starting at 3 before and going to the end. And versus starting at the beginning and going up to 3 before the end. Print game winning, colon, losing, for, now let's do this a couple times, for I in range 5. And those are our results. Let me go ahead and just return, for 1 second, I'm going to return the sequence, the entire sequence. So here we can see that and that's one of the things I love about Python. You can return multiple things, although and so here's the sequences we got and what the winning thing, the last 3 parts of it were. So, but all we really need is those last 3 characters to tell who won. Make sense? So now we want to simulate 10,000 or 10,000 or 100,000 of these things. So let's do that. 100,000. So let's go with wins is equal to 0. Trials is equal to, honestly, it's going to be easier to type trials than 100,000. Because again, I'm human, I'm fallible. I might accidentally type 0, an additional or 1 less 0 than I need to. So I don't need to print out 1,000 of these. That would be 100,000. That'd take forever. It's probably a bad idea. So instead, what I'm going to do is, here's what I'm going to do. What I'm going to do here is I'm going to say for I am range of the trials. I'm going to say if I'm going to say result is equal to game. I could make this shorter, but I'm not going to for the sake of clarity. Game is equal to result. I want the result of a game with this winning and this losing sequence typed in. Okay. And if result equals winning, then wins plus equals 1. And that's it. That's all I need to do because I've done all the hard work in the other function. Let's go ahead and now, and so now for the last part, I need to actually calculate the win percentage. So I'm going to say print. We'll go ahead and do, oh, this is redundant, but I'm going to say print wins, trials. So wins, Actually, I'll go ahead and say, let's print out the trials, the wins. The losses are just simply the trials minus the wins. Anytime I didn't win, that was a loss. And then I'll do wins divided by trials to get the percent, to translate that to percentage, which is useful in case I do something that's not 100,000. So the end result is that Professor Rosen wins 75% of the time and the player wins 25% of the time. In fact, this was the worst. This is like one of the worst possible outcomes, right? It was supposed to be an even chance game, but the odds are very much in Professor Rosen's favor there. It's very weird talking about myself in third person. I do not like it. Why do the odds be like that? Why are the odds like that? It has to do with the fact that this is a game called Penny's Game, and that the only way for the player to for one person to win is to pretty much win outright. Notice over here, the only way you won was by flipping 2 heads in a row. If you didn't flip 2 heads in a row, then once you flip 2 heads in a row, you're guaranteed to win because as soon as you flip a tail, because if you flip another head, that's still 2 heads in a row. What I've done is that because Professor Rosen chooses his sequence second, he's able to choose a sequence which subsumes your sequence. So anything that starts with a tail, he's tail heads. So anything so if he throws a tail before 2 heads are anytime before 2 heads are found, he wins. So it's over here, tail, tail. So we threw a tail before 2 heads. So tail, tail, head, tail. And as soon as we find 2 heads, I'm winning. It's impossible. It's literally impossible for you to throw 2 heads before and then a tail if I've already thrown a tail. If you want a more thorough explanation of it, let's Google number file Penny's Game, or check out the Wikipedia page on it. I don't want to go into too much, but it is fairly awesome. And the strategy is pretty simple. Whatever the first player chooses, if you want to be able to have better odds than them, you choose whatever the opposite of their second choice is, and then put in their first and second choice. And that basically is that and in any case where the sequence is not immediately the first player's choice, the chances for the first player getting their sequence beginning, the opening 2 choices, are usually the chance the second player will be getting their full sequence. So it's a trick. Yes, these 8 results are equally right. So the 8 results I give are equally likely to occur independently if we were to be throwing and collecting data on 3 different, if I flip 3 coins in a row, these results are all equally likely. But that's not what was being asked here. We were asking, let's flip coins until one of these results comes up. Until one of these 2 chosen results come up. And that's a different statistical question. It's a subtle one. And that's why people are able to get scammed. Another similar one I might give out is kind of the birthday problem bet, which is basically in a bar betting that 2 people in this room share a birthday. Let's see how many people are in here. I'm not going to do it because collating the results would be annoying, but we've got 80 people in this room. I'm almost certain that some of you share a birthday, and we can kind of show that via a Monte Carlo approximation. Okay, so let's go ahead and do that one. Okay, so for the birthday game, how do we do that? Okay, So let's, for simplicity's sake, assume there's only assume there is 365 days in the year. Okay. Doesn't really change much, but it just makes it easier to ignore leap years, as we've found in previous in-class exercises. Jen birthday. So I'm not going to care about April, May, the month, or whatnot, or I'm just going to go by the day of the year, which is that I'm going to return a random.rand int. I think it's 1 through 365. That will generate a random birthday. Make sense? So the birthday paradox states that if you've got a room with more than 35 people in it, there's even odds that 2 people share a birthday. I know it sounds crazy, but let's go ahead and validate that experimentally. Let's go ahead and check birthday paradox for n people. Okay, so let's go ahead and generate dates are equal to I'll make a dictionary. Okay, and all I'm going to do is I'm going to count the number of occurrences we have. Actually, even better, I'm going to use a set. Right, set accepts only unique birthdays. So if dates, oh yeah, totally. If it's in Python, it's fair game. If you don't have to download an external library like network, if you don't have to download an external library via pip or something, it's fair. If it's something that is built into Python, like math or random, and you can just import it, or it's just built in like sets, it's fair game. And even then, you could make an argument for something that has to be downloaded, like NumPy, if you really wanted to. Although that's bringing a sledgehammer to, you're bringing a sledgehammer to the problem that doesn't really need it. Okay, so what we're going to do is for in range n. So doing this n times, what am I going to do? I'm going to say dates is dot add Jen birthday. Okay. And then very simple, return n equals len of dates. So check to see if the number of people is equal to the number of different dates that there are. So again, so what does this do? It's kind of like a list, except when I do add here, if it's already in dates, I'm going to throw it out. I'm going to ignore it. So print Jen birthday paradox 5 people. So that doesn't really show us much. So check birthday paradox anyway. Legends is equal to 0. Go ahead and start doing this. So let's call it matches. Same birthdays is equal to 0. So trials. All I need. Trials. And we're going to start off with just 2. people. Okay, check birthday paradox 2. So this is a returns true or false. If there is a birthday paradox, then we say same birthdays. What does the blank mean in the for loop? It means we don't care about the I or any variable there. We're just not going to use anything. So same birthdays plus equals 1, print same birthdays trials. Same birthdays divided by trials. Okay, and makes sense. Oh, makes sense that we wouldn't get a match. You've got to, let's go and up this, right? You pick one person at random, they have a 365 chance, and the other person has a 365. So there's 365 by 365 kind of combination. There's a lot. That's maybe a few too many zeros. It's probably a few too many zeros there. Yes, it is. Yep. So we're just not getting any matches. So let's go ahead and up this from 2 and from 2 to something I know will work. If there's 365 people in a room,
Professor, I think because when I call this dot add a Jane birthday, the birthday, no, the curly brace, the
did I forget to put something in?
yes.
What did I forget?
I think for the dates add thing, the Jen birthday should have the parentheses.
Oh, yes.
Yeah.
Yeah.
Of course. Thank you. This is what happens when you code and talk at the same time. Thank you so much. So now if we do 2, there we go. And I want to return not equal, so if they are not equal, then we've had a birthday paradox. So if there are n people, but there are less dates than that, less unique dates, then we have a birthday paradox. So here we can see that basically less than 1% of the time, the 2 identical people have a birthday, which makes sense. But if we up this to suddenly 35 people in the room, there's 35 people. Interestingly enough, we'll see that oh, phooey, come on. Yes, I want to kill it. Let's do 100,000, 10 times less. Then 81% of the time, there's going to be a match for birthdays. I'm going to shorten this by simply saying, hey, if n, sorry, which I wanted to do in the first place, but if so let's see. Let's go ahead and shorten the runtime by adding a short circuit. If Jen, I mean, I could, but we'd get a ton of them. You can check this for yourself. So if date is equal to Jen birthday if date in if date in dates, then we can just simply return false because we've had a duplicate already. Other else dates.add the date that we just generated. And then finally, if we get to the end, return true. This should be a bit faster, I think, because we'll short circuit if there's a match. So, oh yeah, sorry, other way around again. Keep getting it confused. If there's a birthday paradox, return true. And we can see this. So let me go ahead and lower the trials to about 10. And what we can do is that we can return what we'll do over here is that we will print date in the dates and otherwise we'll just print out the dates if there is no match. So what we found over here is that, right, we're generating numbers and then we hit a 94. We generate another, we've generated these numbers and then we generated another 94, which we had already generated. So that means that we just found a person that has the same birthday as somebody else. So notice what's going on here. The more people we keep adding additional people to the checked off birthdays, but as we check off people, it becomes more likely that we find a collision, like over here, 243 and 243. So it's not, so again, we're not asking you and I share a birthday, but do any two people share a same birthday? So let's go ahead and work on this last problem that was actually a problem that I did. Have I done I think I've talked about this Monopoly problem, but did I ever solve it in class or no?
No.
Okay. So in the board game Monopoly, that's a complicated game, but what we're focusing on is the dice rolling part. In the board game Monopoly, two players move around the board by rolling a pair of six-sided die. Rolling doubles, such as 2 3s or 2 5s, is very good because that means that you can roll again. It essentially gives you an extra mini turn. However, if the player roll, and you can do this again, so you get triples, awesome. But if you roll if you roll one double, great. If you roll two doubles, also great. But if you roll 3 doubles in a row, then that's bad. So if you roll 2 3s, 2 5s, and then 2 1s, that's bad. You go immediately to jail, right? But otherwise, you take your turn, you roll doubles, you take your turns and you roll again. You take your turn and if you don't run thing, it's just one turn. Everybody understand? Hopefully you've played Monopoly at some point. Okay.
Professor, not all of us were, stuck in on Saturday, from not being able to use electronics and just having your siblings there.
So maybe true, but all that's important here is just simply, we want to write a program that simulates 100,000 Monopoly turns. Extra rolls due to doubles count as the same turn, where a turn is a single roll of the dice or more if the user rolls a double. Your program should print out the number of rolls without a double, the percentage of rolls with 1 double, 2 double, 3 doubles. So this sounds a bit daunting. So let's look at the rubric. And this is what I suggest you do for the actual question. 10 points, simulating 100,000 dice roll. Okay. Handling doubles, handling 2 and 3 doubles in a row, presenting the data in percentages. Okay. So this is a lot. Let's do 100,000. Let's do the simulating 100,000 dice roll. I think I can do that, right? So let's go ahead and okay. So again, we've already got random imported. So def roll return one. So rolling a, so I'm going to call this roll one, roll d6 just to represent the fact I'm rolling a 6-sided die. Return, and I'm rolling a single d6 because I care about what the right. If I'm what I care about is that not the total of the dice roll, but if I roll 2 dice, do they come up on the same face? So return random dot rand int 1 through 6. The 2 big random ones you should know are random. I think random dot rand int, random dot choices, and random dot sample. I think. So return. So in other words, choosing something with replacement and choosing something that with sample, basically it's choosing a subset of a collection, I believe. But if you need to like do a statistical stuff, check out, like get multiple things, check out what random actually, the random functions actually do in the documentation. So def, the main one is to do for the exam, though, I can guarantee that pretty much what you need is random dot choice. Make sure you use that. So def random. So now let's go ahead and say def actually, let's go ahead. I think I can go straight into it actually. Rolls. So turns is equal to 100,000 or I in range turns, and it just said I have to simulate 100,000 of these, right? So random dot rand int and 1 by 2, because again, well, I'm not going to roll them and add them together. I want to know if they match. But that's it for simulating 100,000 dice roll. That's all I have to do. That's 10 points right here for this part. I've simulated 100,000 dice roll. Great. You'd be surprised how many people left that blank and didn't bother just trying to simulate 100,000 dice. Put anything. Put something down on the board, for God's sake. Make, you cannot, I cannot grade you on nothing. So try your best to follow the rubric. So now it wants us to handle doubles. Okay, that's easy enough. If die 1 equals die 2, then that means that we had a double. So doubles, or well, 1 double, because right there's the possibility I could get 1 double, 2 doubles, or 3 doubles, right? Okay, that handle. Ooh, I guess that's technically another 5 points. Now I have to handle 2 and 3 doubles in a row. Okay, so if I roll a double, that means I go again, right? So, but it's part of the same turn. So technically, let's go ahead and see what we need to do here. Die 1 is equal to so we've re-rolled it. If those 2 things are the same, die, so this is my second roll for the turn. If die 1 is equal to die 2, that means I did a triple, or sorry, 2 doubles. So now I'm gonna have to swap this around. Yep. I'm just kind of showing the logic behind it. So die 1 is equal to die 2, 2 double. Okay. Okay, otherwise 1 double. And then finally, I have to do this one more time, right? Because it's possible to do get 3 doubles in a row. And that's the most you can do it. So if, and this one's excessively nested, but that's okay. And we'll just have to move this over here again to the bottom. Okay, so now I'm up to 18 points on this problem. And again, all I'm doing is just counting. So here, if they match, then that's probably if I get 2 matching die, I roll again. And if those don't match, then I rolled a double this turn. Otherwise, if I roll 2 dice and they match, and I roll them again and they match, and I roll them again and they don't match, then I got 2 doubles. But if I roll 2 die and they match, and I roll them again and they match, and I roll them a 3rd time and they match, that is 3 doubles. That's all that logic is. Now let's finish it up. I want the statistics. Print trials. The number of turns with no doubles. Well, that's easy enough. It would be trials minus 1 double plus 2 doubles plus 3 doubles. Right, it's whatever we didn't have, and then we'll do 1. And then we want percentages. So it wasn't trials, we called it rolls. Did we call it rolls or turns? We called it turns. Turns. 1 double. And hopefully this should end will be, if this adds up relatively to 100%, then we did it correctly. 2 double. 3 doubles. And we see that it does add up relatively to 100%. So 83% of the turns go without a double. That makes sense because that's 5 out of 6 of the times. Then we roll them, and 5 out of 6 of the times we roll the second one, that's going to be a single double. But then we get, this is the number of times we have 2 doubles in a row. So in other words, that's a 1 in 36 chance to get, so it's a 1 in 6 chance to get 1 double in a row. 1 in 36 to get 2 doubles in a row. And then 1 in 6 times 36 to get 3 doubles in a row. Which makes sense. But notice how I basically followed the rubric to get my answer or to do this, right? It was a big problem. And I'm like, I'm just going to follow the rubric. Okay, simulate 100,000 of these dice rolls. Now I'm going to handle the doubles. It's almost as though the rubrics are a hint. All right, I went over time, so I'm going to go ahead and end class.
Thank you.